Hello all, welcome to TechGeek webinars. The topic for today's webinar is Java Design Patterns, Useful Variation and Factory Method. This webinar will help us understand how different patterns work together in real-life component development. We are delighted to have Mr. Hemant Kumar Dugar, Training Consultant at Login to Java, as expert speaker amongst us today. Mr. Hemant is a motivated achiever with more than 15 years of significant progressive experience in IT. PMP certified professional having a sound base including core concepts in managing projects and processes at various knowledge areas. Gentlemen, the presentation will continue for 45 minutes. You can ask your questions to the speaker by typing in the chat pane available. So without further ado, I request Mr. Hemant to continue with the session.
Yeah, this is Hemant. Just wanted to confirm, am I visible and audible?
Yes, your screen is visible and you're also very much audible. Let's get started the webinar. Thank you.
Okay, yeah, thanks. Good afternoon, everyone. Today's topic is basically Java design patterns, factory method, and its variation possibilities. Factory method actually it belongs to creational patterns. Creational patterns are the ones that creates objects for you. Rather than creating objects with the new keyword in Java, these creational patterns actually creates objects for you. Factory method is one of them. Also governs the object instantiation process that hides the complex logic involved in object creation from the clients. So two major things. One is it creates objects for you. Second one is it hides the complex logic involved in object creation from the clients. What does client mean here? Client means here, basically client here means that is a part of your program or code that is using the factory method pattern. That particular portion of code will be treated as client over here. So let me take an example. Suppose you need to work on an Excel file in your Java program. You want to convert some of your program data into Excel file and do some operations on that Excel file through Java application. So how will you program it? The standard way is definitely you will need to find some of your jar file which can work on Excel file. So that third party jar you need to use, or if you are having your own jar to work on Excel file, that you can use. So include that jar file in your program and start coding inside your program where you need to actually include the functionality that you want to work on Excel file. So you prepare your data, convert it into Excel file object and use different methods from that particular jar file to create a proper Excel file within your requirement. So this is a standard straightforward approach that normally comes in the procedural programming language. Another thing that you can do is you can create a separate wrapper around the Excel jar, third party jar that you are using. You can name it my spreadsheet or my Excel file, and then create all the needed functions that are required in your application. What I mean to say is, suppose this is your jar file that is ready to work with Excel file. This is your application, client application. Then you create a wrapper and create all the needed functionality which will be using this jar, and then your program will use the wrapper to convert the data into Excel file. So this can be another approach. So what will happen if there is a new requirement to work on CSV file? This is your Excel file, and now there is a requirement to work on CSV file. You need another jar and maybe some more different type of files that you need to work on, maybe on PDF also. So you need to convert your data into Excel, then CSV, and then PDF. So this type of coding is not good enough. Actually, many developers works on same part of your program simultaneously. So again, there is a problem of maintaining the code. The method names in different files may become different as different developers working on different type of files. Maintaining consistency in code becomes difficult. At a later stage, the code understanding and debugging will be difficult because the whole code will be scattered around over here. So this may be scattered and maintenance will become difficult, even debugging will become difficult. Test cases needs to test each and every file. So if any new changes comes, you need to modify in all application using the common code. So suppose another application is requiring the same code that you have written over here and over here. So what you will actually do is just copy this code, paste it in the new application, and then do some changes, modification, do all the testing, and then you start using the same functionality in another application. So copy pasting the code is again a problem. Why it is a problem? Because if you need to change or if you need to add a new functionality into Excel file or CSV code, you need to do that change in all the application that is using that particular copy pasted code. So this is actually a problem. This is not a good coding practice. So you need to develop a framework for your application. Such applications are typically organized around document or files. So the earlier example was basically for Excel file and CSV file. Now we are taking another example, another context where application typically needs to work around document or files. The type of document can be text, word processing document, or spreadsheet document. Operations like create, open, create the file, open file, edit file, save the document, and the framework must be robust, reusable, expandable, and easy to maintain. So this is the context. We need to work upon this framework. Just go through this class diagram in a minute. See, now below this red line is your component that you can develop as a separate jar, or you can develop it as a separate package, or you can develop as a separate module in your application. Client actually requests the document factory, create the document, and it will pass on the type of the document that it needs. This document factory create document method will have code, proper code that will understand the type and creates a proper spreadsheet, a proper type of document, either spreadsheet or text document, and returns the iDocument interface to the client. Client will use iDocument interface to operate on the proper instance of the document. So here the important thing is iDocument interface and the document factory. Client requests document factories create document method, which is a factory method, by passing a proper type of the document that client requires. This method will actually create the object of the requested document type and then return the iDocument interface reference to the client. With that reference, client actually uses the proper document. I think this class diagram is easily understandable now. Now see the expandability, ease in expandability. Suppose in future you might need to work on Word document. What you need to do in that case? You implement this interface iDocument in your Word document and then give a proper code in the factory method to create this Word document. So it is easy to expand. You need not to change much in the component. You just need to change a line in the document factory for the proper new type of the document to be created, and then create a separate class that will implement the iDocument interface. So when you actually debug or test your newly developed code, you need not to test this portion, the text document and spreadsheet document. Just test your Word document. So it is easy to expand, easy to maintain. Now what about reusability? If you see this particular line I have drawn, below this is the component. You need not to copy paste the code. You just create a jar out of this component and use it in your other application as it is. So you need to keep the versioning of the jar for the modification and then ship that particular jar to all the application that is using this code, this particular component. So it is easy to reuse also. And there is only a single point of access for creating any type of document, and that is this factory method, create document inside the document factory. So this is a basic classic way of implementing factory method. So the same description, the client needs a document, but instead of creating it directly using the new operator, it asks the new document to the factory, providing some information about the type of the object it needs. The factory instantiate a new concrete document and give the type and the return to the client. Basically it returns the interface reference. The client uses the document without being aware of about their concrete implementation through the iDocument interface. See the code, example code. This is your iDocument interface, which will have all the required methods, create, open, etc. That will be common between all the documents. Text document implements iDocument and implementation will go over here, and spreadsheet document implements iDocument and the implementation goes here, and similarly a Word document implements iDocument. Any number of type of document can implement iDocument. I think this is pretty simple. Now see the document factory code. We can have a static method create document. This is your factory method. You can supply the type of the document that you needs to create. If text equals to type, suppose your type is text, it will return a new text document, or spreadsheet, it will return a new document spreadsheet. And another if condition you can have over here for your Word document or PDF document or any other kind of document. If you see this particular class, it can be very easily understandable that it is a singleton class. It should be a singleton class. So you can implement a singleton pattern over here to make it a document, to make the document factory a singleton class. Within the singleton, if you go for a particular variation, it can be a static singleton, because there is no need to create an instance of document factory over here. You just create a static singleton document factory and have this factory method, static factory method, create document. Now, another context. There are common operations between different type of documents like get title, get creation date, get modification date, etc. So this is another variation you can say. If we have some sort of common implementations for some of the methods in all the types of the document that we are creating through the factory, what should we do? Just give it a thought for a few seconds. I think the answer should come in your mind. What you can do is, you can have an abstract document between the interface and your concrete implementation, where all the common implementation methods can be coded over here in abstract document, like get title, get modification date, get file name, get file path, get creation date. All these methods can be here in the abstract document. So this is another possibility for a factory method. For the common implementation, you can have abstract class with interface. So if you see, this is a classic example for using around 4 design patterns or 3 design patterns to create the 4th one. The first design pattern, that fundamental design pattern we have used, is the interface implementation. The second fundamental design pattern that we have used is interface with abstract class. The third design pattern that we have used is singleton, and using these 3 design patterns we have created factory method design pattern. Factory method variations. There can be various ways of implementing factory method. Two main variations are data driven instantiation and instantiation by configuration. What all examples till now we saw are basically data-driven instantiation. This is a general case where the class of the object to create is determined when the object creation is initiated. Whereas instantiation by configuration, it is a less common in use, or less common required actually, where the class of the objects that will be created is always the same and is determined before an object's creation is initiated. So one factory for one type of object. If you have two different type of objects to be created by factory, there will be two factories. So a bit confusing over here, but we will soon be looking at a good example that will be useful to understand instantiation by configuration. Okay, let me take an example for you. Suppose a company sells point of sale terminals or systems. That particular system, that POS system is responsible for communication with the remote computer to process credit card payments. Right, POS terminal to process the credit card payments. So its classes expect to send message to the remote computer and receive the response by using objects that implement a particular interface. The exact format of the message to send will depend on the company that processes the credit card transaction. So there can be different companies for processing the credit card payment, like Visa, like MasterCard, like American Express. And that particular point of sale terminal requires to process the proper type of credit card. For each credit card processing company, there is a corresponding class that implements the required interface and knows how to send the message to the company and expect the result out of that particular request. So there is a corresponding factory class also. Okay, let's see the class diagram to understand it in a better way. A program may use a factory object that always create an instance of same class if the class is determined by some configuration information. Right? This is what we have discussed with the credit card example. So see this particular class diagram. I will give you a minute to go through this class diagram and then we'll explain you. Just have a look at it. See. Below this red line is basically the component, the factory method, which is using factory method for processing the credit card. So this particular component can be firmwared into POS terminal. POS terminal, when you put a credit card in the POS terminal, it will read the configuration out of the credit card. With looking at that particular configuration, when the POS actually reads the configuration information, this information tells the POS that it is to pass credit card transaction. Either suppose we just have two types of processing companies for processing the credit card. One is Visa and one is MasterCard. So this information, the configuration information, tells the POS that which credit card transaction, either Visa or MasterCard, needs to be processed. So looking at that configuration, so based on that information, POS creates either Visa CC factory. So it will send that request. So again, see, this is an interface. Interface credit card process factory. This interface will give the factory instance for either Visa credit card or for Master credit card. So this particular factory then will be used to create the proper processor, either Visa processor or MasterCard processor. These two processor, concrete processor class implements interface credit card processor, which actually communicates with the company, credit card company, to process the credit card. Right, so all that particular implementation will be within these two class, which will be communicating with the companies, either web services or companies implementation for Visa or MasterCard, and then processed response, receives the processed response and then give the proper processing results to the point of sale terminal, which will then finally print out a slip that payment has been successfully done. So see this, if suppose there is another third American Express credit card needs to be implemented. So what can be the modification possibility? You can have another factory for American Express credit card, or even that particular American Express company will give the implementation that can be firmware into POS. What implementation that can provide? This is the interface that will be given to the American Express that we need these interface implementation. They will provide the implementation for processing the credit card for American Express through this point of sale terminal by implementing and sending two classes. One is ICC process factory, another one is ICC processor. That is interface credit card processor and interface credit card processor factory instance for American Express factory. So this is basically configuration driven factory method. Data driven, we have already seen example. The class of the object to create is determined when the object creation is initiated. The determination is usually based on information passed to the method, like the type of the object needs to be created, and the sequence of if statement works well for create document method that have fixed set of product classes to instantiate. Product classes here are text document and spreadsheet document, our previous earlier one example. So if you see this code, there is a limitation that you can process two type of documents over here. For third type you need to modify the code. So another context is there are new document types and these should be dynamically become the part of framework. So till now we have this static inclusion because for a new document you need to modify the factory, but the new requirement is they should be dynamically become part of the framework. What does this mean is we need not to modify the document existing code. Instead, we just supply a new document implementing the iDocument interface, and this should work without any modification in any of the existing code, including the factory. Now see this example, class diagram. What we are passing is the class instance of your document class. The remaining portion is same as it is that we saw in data driven factory. iDocument, abstract document, text document, spreadsheet document. Now we need to have a Word document. We need not to modify any of the portion in the existing code. We just create a new class that will work on Word document and inherit the abstract document. which in turn implements iDocument. That's all. How it works? While creating the object, we ask document factory to create the document, and we will pass on the class object of this class, Word document class. And inside this particular create document, first it will check whether it implements iDocument. If it is not implementing, throw the exception not supported document. If it implements iDocument properly, in that particular case, you can create the instance using reflection APIs by this class instance. And that document will be returned to the client. So this is dynamically inclusion of new documents in your factory method pattern. Any number of new documents that you can implement. So think of this is your application and you have developed a component, or you might be using third-party component for maintaining the document, and that is based on dynamic inclusion of new documents in the factory method. You can create any number of new documents by implementing iDocument interface in this particular component. That's all. And pass on the class instance wherever you are using wherever you are creating the new document. It will give you the new document created because this class is given by you to this component. You can create within the component new document. You can create new document in your application. So this is as easy as to expand. Not a single line of code in existing component will be changed. Just create a new document and that will be included in your application. If we look at the component development perspective, we just see this interface working properly. And it is making the component reusable, maintainable, expandable, and robust. Now see, we have a iDocument factory interface in place now. By keeping this interface in place, see how easy it will become to create new factories in your application anytime. New factories that will give different new documents implementing this interface. So if you see now, it is becoming closer to the configuration driven factory method. So this is as good as having both the things in one implementation. Data driven, the already existing class diagram. Having an interface iDocument factory, it can be expandable to configuration driven factory method also. So this is really a good example of having a factory method that is very easy to reuse and expand and maintain. If we see Java API usage, URL connection is an example. URL connection plays a role of client in factory method pattern. It delegates the work to get content method to the content handler object, where content handler is an abstract class that serves as a product class and knows about handling a specific type of content. So it is an abstract class content handler, whereas the way that URL connection object gets the content handler object is through the content handler factory. So particular content handler can be taken out of this factory. The URL connection calls also has a method that is called set content handler factory. So using this set content handler factory, you can change the factory also, which is actually very useful in applets to provide factory object for URL connection within the applet. for the applet factory. So if you go in detail of URL connection, you will understand it properly, how this factory method is working over here. Related patterns are hashed adapter pattern, hashed adapter objects. It is useful if the set of classes that a factory creates may change during the runtime of program. Template method instantiation by configuration information often uses template method pattern. Singleton. Factory used here are mostly the singleton. All the factories that we have used in our examples should be singleton. Abstract factory creates a method set of objects. Creates a matched set of objects. Is a compound pattern and use the factory method and interface pattern. So actually factory abstract uses factory method, but it creates more than one objects, matched object set for the client. So if we see advantages, disadvantages, pros are hide concrete classes from the client. So client will not be aware of what the implementation inside in the concrete class because it accesses it through the interface. The code deals with the interface, so it's actually easy to expand, maintain, reuse. Advocate for the component-based development. This is what the most important part is. You, all of you, I think most of you are working and in your day-to-day coding. So you should start thinking in terms of component. Just you have to go away from the procedural programming or coding thinking. So think in based off object, even object, what I should say is object-oriented component-based development. Cons are, since the pattern relies on using private constructors, the class cannot be extended. Okay, so let me explain it. We have iDocument interface and we have concrete implementation text document. Right. So we don't want that apart from factory, the instance of text document should be created from anywhere else. So we need to make the constructor private. So you cannot extend it. Refactoring an existing class to use factories breaks the existing clients. So if you are having existing application and you are using you are creating objects at so many places, and if you want to convert it to factories, so your existing client code needs a lot of changes and refactoring. So what we have saw in today's lecture is we saw the classic data-driven factory method, we saw the dynamic data-driven factory method, we saw the configuration-driven factory method, and a mix of data and configuration-driven. And all these, in all these variations, if you have some common functionality amongst the type of the concrete objects that you are generating from factory, just give a abstract class in between interface and concrete implementation for the common implementation. So here is an assignment for you. Let's understand the assignment first, and then you can practice it at your home for using the factory method. An application requires file parser. Files can be of two types, either CSV, that is comma separated value file, or fixed length value file. The common functionality provided will be get next record, parse the record, get file name, get file size, and what other functionalities that you can think of for the parsing. So you need to develop a framework to facilitate the parsing of these two types of files. This is the first requirement. And the second requirement is the framework should allow dynamic inclusion of new type of file parser. What does this mean is, Suppose you want to parse the Excel file. So just you need to create a concrete implementation for parsing the Excel file, implementing the common interface. That's all. So dynamic inclusion should be there. So this can be a component for parsing files, and this can be a good exercise to practice factory method, singleton, interface abstract superclass. All the 4 patterns you can practice in this particular assignment. Some of the questions that can be of, before I go to the questions you have, let me first take some common questions. The common questions can be, can you give some real world example from Java API? The one that we have seen is URL connection. Another one, there are lots of examples. I will take a few. There is a method in object class toString. toString method actually create a string object out of your class, whatever class you have. So by default it will return the reference, but if you implement the toString, it will create a string out of your suppose integer class or whatever class that already exists or you create. You can override toString. So this toString method is actually a factory method that will create string out of your object. Then another example is getInstance. Class.getInstance. This will actually return the class object of any of Java class. Another is class.forName. So there are so many factory methods that you can find in Java API. Another common question is, how does factory method promotes loosely coupled code? So this we have already seen in so many examples that we can develop a component out of factory method easily with data driven as well as configuration driven. So that component is very loosely coupled and you can reuse it in different applications. Discuss the situation where you should avoid dynamic data driven factories. Now this is a very good question. Dynamic data driven means which can take new concrete implementation without any change in the code. And is there any situation where this is not needed? Okay, let me tell you one example. Suppose I am a product company, I have a product company, and I have developed a component, a jar component. Do you think I will use dynamic data driven factories in my component? I should not use. If I want that all the development should happen by my company or for my product. If I keep a dynamic data driven factory, my clients can create code, implement interface and just pass on the dynamic factory to get the output or to get the proper implementation. But if I have my factory method with ladder of if-else statement for creating objects, third part clients cannot create their implementation and cannot pass on different types that are not in the component to the factory method. So if you look at the situation, there are situations when static data driven factories are required, especially when you are a product company. But definitely if this is an open source code, you need to create dynamic data driven factories so that the user or the customers or the clients of open source can create their own code with the dynamic data driven factories. So let me go through the questions one by one. Umesh has asked how the wrappers are created. Wrappers can be created easily with either containership if required. You can take the object of the class that for that you are creating the wrapper, or you can inherit it depending on your requirement. Another question. Ramesh, if you have third-party interface in the first class diagram, first class is basically static data driven. Does your client code varies or same? The client code should be same. How does it varies if the interface is same? How does implementation wise it differs whether the interface is in your client jar or in your own application or third-party jar? If the interface is always public and you can implement it within the component or in your application or in your module anywhere. But definitely in the first diagram, the factories cannot be, you cannot pass the object to the factory or the type to the factory, because factory is basically static in nature. Dynamic inclusion is not there. So for making the factory dynamic, you need to have a factory interface. That I have already explained in so many examples. Salil has asked if we need to convert documents to another type, that is CSV to XLS, which class will have conversion method? So this is a different requirement, Salil. What example I have taken is from convert the data to CSV or to XLS. So within the example that I have taken, it is not possible. The requirement is different, CSV to XLS. So either you need to create a different component from one type to other type, where you can have a in-between common type. So you can convert any type to the common type, one component, and then common type to any other type, the second component, and use this component together. Another question. Santosh has asked, is it always good to make the factory method class a singleton class? Definitely it is always good, but there is there, in our example, I have taken an example of configuration driven. So in configuration driven, I will explain here. In configuration driven, we have an interface and our factories are implementing this interface. So if you are implementing an interface, it means you can have singleton, but static singleton is not possible. You will have a singleton instance over here. But in the first example, data driven, static data driven, you can have a static singleton. But all these get methods can be in test doc, class, and spreadsheet doc, etc. Abstract document class. Deepak Sharda. Deepak, you can have all the get methods in the concrete classes text doc or spreadsheet doc. But think of having around 10-12 documents, concrete documents, and then there is some change in creation date method. You need to change at all the documents. What I said is the common implementation. You should move to the abstract class, right? Another question that I have from Venkat Raman. If we made document factory as a singleton class, then what are the necessary steps to be taken care to avoid any unnecessary behavior in the multi-threaded environment? So the answer will be a bit longer, so I will tell Venkat Raman to go through my earlier session of singleton to get out of this problem. That is available at TechGig. Kamaldeep Bhatia, why do we need to create different factory for different types? Can't we have same factory calling the different processor? Kamaldeep, I will leave it to you. Just think of the scenario that I have explained for the credit card. Because, okay, let me explain. As the credit card processors are different for different credit card companies, and credit card companies need to supply the implementation, so they will supply the factory with them, configuration factory, because configuration is available before creating the object. Before creating or calling the factory, you need to load the configuration also. G. Balachandu, if text-doc constructor is private, how do we create instance of it in factory? Very good question. Chandu, in one of my earlier lecture, even I will explain over here again. Normally, we need to avoid new. So you can have a small factory method inside your concrete class named get new instance, a set method that will give you the instance, and it will prevent from inheriting. Another question I just answered the Chandu's question is by Nilesh, how to hide concrete class so that user can't create the object of them directly and forced to use factory class for creating object. So the same answer, you need to create a factory method inside the concrete class. A static factory method, get new instance, that will return the instance and make the constructor private. I am skipping some of the questions of similar type that I have already answered. Deepak has asked how to avoid this dynamic data factory creation in Java. Dynamic data factory creation. If you are talking about dynamic data driven factory creation, I would rather say do not have data iData factory interface. Just have a hard coded if else ladder in your factory method. Atul has asked how the dynamic inclusion related to the IOC as implemented by J2E containers. This is the functionality is very much similar, where you can just pass on the type of the class and you will get its instance ready for use. I'm skipping some of the questions which are not directly related to this lecture. Sonali has asked what is the necessity of using the abstract document for using get, modify, date, etc. functions. Common implementation functions. I have already answered this. If you have a common implementation in your concrete classes, instead of writing or duplicating code in each of the concrete class, move it to the superclass, abstract superclass or superclass, so that any code modification needs to be done at only one place. Chandu has asked, then in your example, I see new text document call from the factory class. Your comments, please. Yeah, there are other things also that in my code example you might find not complete, like what I have said, that factory class should be singleton, but in my example it was not singleton. The important is the concept that I have explained. Code might have been written shortly or in concise way because of the availability of the screen and visibility to the user. Sudhakar has asked, do we need to take any special care for avoiding the cloning of singleton or factory object? Definitely we need to take care of cloning in singleton as well as in factory. So that you can do by overriding the clone method. Either you can throw the exception or give, I think throwing the exception can be the best way. So I think I have answered almost all the questions, all the relevant questions. So I have done from my side. Thanks everyone.
Thank you, Mr. Hemant, for such an informative session. I would also like to thank all the attendees for making this webinar a big success. The recording of this webinar will be made available on techgeek.com by tomorrow. The next session in the TechGeek webinar series is happening today at 5 p.m. Topic is Innovation in Financial Technologies. Speaker is the CTO of Polaris Financial Software. So see you all at 5 p.m.